നമസ്കാരം. സിവിൽ എഞ്ചിനീയറിംഗിന്റെ ബേസിക്സിനെ പറ്റി പഠിക്കുന്ന പുതിയൊരു വീഡിയോയിലേക്ക് എല്ലാവർക്കും സ്വാഗതം. In the last video we have seen what is concrete, how the concrete is prepared, what are the different types of mixes, how it is represented, what is compressive strength of concrete and how it is tested. Now in this video we will be studying about flexural strength of concrete. What is flexural strength of concrete? Flexural strength of concrete, it is also called modulus of rupture, is an indirect measure of tensile strength of unreinforced concrete. What are all the factors which induce tensile loads in the concrete? External loading, warping, corrosion of steel, drying shrinkage, temperature effects, etc. are the main reasons which causes tensile strength in the concrete structure. Concrete is strong in compression, but it is very weak in tension, because of which the flexural strength accounts only 10 to 20% of the compressive strength. The determination of flexural strength is an important factor in the design of pavements, especially when there is inadequate subgrade support. Tensile strength of a member cannot be found directly, as no apparatus or specimen model has been developed eventually to distribute the tensile load to the member. We have seen that we have tested the compressive strength, we have casted the concrete mold, and we have applied the compressive load directly on the specimen using the compression testing machine. As per IS 516, we use 2-point loading test to find out the flexural strength of the concrete. The flexural strength measures the ability of the concrete to resist the deformation under the load, which is crucial in assessing the durability of the material or durability of the structure. When a simply supported beam is subject to bending, tensile stresses are developed at the bottom of the beam, and once the tensile stresses exceed the flexural strength of the beam or the concrete, cracks starts to occur at the point of maximum bending moment. The load causing the crack and the pattern of the crack can be used to evaluate or calculate the flexural strength of the given concrete member. Now, what is a simply supported beam? What is maximum bending moment? All this we will be learning in the next coming videos. Let's see the procedure for calculating the flexural strength of the concrete. As we have seen in calculating the compressive strength of the concrete, we have casted cube molds of size 15 cm into 15 cm into 15 cm. Now here, for calculating the flexural strength of concrete, we are calculating a concrete beam. And as per IS 516, the size of the concrete beam shall be 15 cm into 15 cm into 70 cm long, or 10 cm into 10 cm into 50 cm long, depending upon the size of the largest nominal size of the aggregate used in the concrete. And here also, in the concrete beam, after filling the concrete is compacted using tamping bar, and here the tamping bar shall be a steel bar weighing 2 kg, 40 cm long, and it shall have a ramming face of 25 mm square. The mold shall be filled in 3 layers, each layer compacted with the tamping bar with a number of strokes not less than 30 per layer. And the testing on this specimen shall be made usually 7 days and 28 days. The test specimen shall be allowed to rest in water for 28 days. The testing is done immediately after removal of the specimen from the water and while the specimens are still in wet condition. Reference lines are drawn using chalks at 5 cm from the edges of the specimen on either side to indicate the position of the roller support. Finally, the load is applied until the specimen fails and the maximum load is noted. Here we can see the pictures. As I told, this is a concrete beam mold which we call, and its width is 15 centimeter and the depth is also 15 centimeter and the length is 70 centimeter or 50 centimeter depending upon the size of the aggregate used. And this is the 2-point loading system. These are the two supports of the machine where we are loading the concrete beam, and we are marking 2 lines at the edges, 5 centimeter from this end. We are marking 2 lines, 5 centimeter from this edge and 5 centimeter from this edge. That is this loading line. That is this loading line, and we apply the load from the top through the machine. And once the maximum load is reached, we can see the beam is start cracking at the center. Now let's see how to calculate the flexural strength from the lab test. The flexural strength or modulus of rupture is given by the formula Fp is equal to P into L divided by B into D square. When A is greater than 200 mm for 150 mm specimen or greater than 133 mm for 100 mm specimen. Fp is equal to 3P into A divided by B into D square when A is less than 200 mm but greater than 170 mm for 150 mm specimen or less than 133 mm but greater than 100 mm for a 100 mm specimen where Fb is the flexural strength and A is the distance between the line of fracture and the nearest support measured on the center line of the tensile side of the specimen. Here we can see this is the concrete beam sample which we have tested in the previous machine, and this is the 5 centimeter side we have clearance we have left on either side for loading the beam on the machine. So these are the two loading lines, and we have seen this is the crack developed. This is the crack developed. And what is A? A is, this is the distance from this loading point to the crack, and this is the distance from this loading point to the crack. And A is the minimum distance of the crack from the nearest support. So this is A and this is not A. And B is the width of the specimen. This is the width of the specimen, and D is the depth of the specimen measured at the point of failure. This is the depth of the specimen, and L is the supported length. This is the supported length. That is, from we have seen, this is the loading point and this is the loading point. So this is the supported length. And P is the maximum load applied to the specimen in kg. Here we have applied the load and the maximum load at which the specimen started cracking. That is the. Now let's see the formula to calculate flexural strength from compressive strength. We have already learned how to find out the compressive strength of the concrete, and from the compressive strength what we get by testing the concrete cubes, we can derive the flexural strength of the concrete. As per IS 456 2000, the flexural strength of the concrete can be computed by the characteristic compressive strength of the concrete, and the formula is flexural strength is equal to 0.7 into square root of FCK, where FCK is a characteristic compressive strength of the concrete. This is a comparative of flexural strength and compressive strength. We have seen how to calculate flexural strength from the compressive strength. The flexural strength is equal to 0.7 into square root of compressive strength. So when the compressive strength is 20, the flexural strength is 3.13. When the compressive strength is 25, the flexural strength is 3.5, and compressive strength is 30, flexural strength is 3.83, like that. All these values are given in the IS 456. So now in this video, we have learned what is flexural strength, how it is calculated, and how it is tested. So hope you have learned something new from this video. And if you have liked this video and if you have learned anything new, please support me by hitting the like button. Thanks for watching. Please subscribe to my channel.